All right, well, we're going to give this a shot. We're going to have you guys work on building some expressions and functions here. So as an example, to show you how we might use some of this, one of the things we're going to need to know about sometimes in making things move in reasonable and realistic ways based on their size, height, distance, all this sort of stuff, is about the center of an object. So this is a 3D specific issue, not really a programming issue, but it's really, really important in here. So I do want you to know about the concept of an object center. So when you guys did this with the angel and the Egyptian, moving to and then moving a comfortable distance away, again, when you move one object to another and you use the move to method, then they actually move so that their centers are right on top of each other. And the center, where the center is going to vary by object. There's no rhyme or reason. You just have to click on the object and look. And this is because different animators created the different objects. So for example, we're going to be doing an example with a bee. So I want you to know that for this example, the center of a bee is smack in the middle of his center. It's halfway between his top and bottom and halfway from the left to right. But we're also going to be using a tulip, and the center of a tulip is not probably maybe where you think. It's at the very base of the stem. And a lot of people in Alice have their centers in between their feet. Okay, just so you know, that often happens. So we're going to be working with these two. So we've got our bee center is in the middle and our tulip center is at the base. That's going to be important to know as we do the next clicker question. This is about reading and understanding expressions. So let me give you a brief idea here about what I mean by perfectly. We want to make this bee fly and perch perfectly on the top of a tulip. That means his little feet are just right on the top of the tip of the tulip. That's what we're looking for. This will be the code that will do it. All right. So let's hear from some of you, maybe using things like, did you hear or understand me? Or asking for justification or any of that sort of stuff. What did you guys talk about in your groups about this question? Because it was huge variation. Anybody? Yeah.
My group got what was going on. I didn't, so they explained to me mathematically what was going on, and it made a lot more sense after that.
Great.
So we all agreed that it was 0.35 meters.
Which one, I'm sorry?
C.
C, oh, okay. So okay. Anybody want to tell us how somebody might think it's something else? Because a lot of people, we got somebody up here will tell us. If you can figure out how to get it wrong, then you can usually get another question right. All right.
So our group chose B.
Uh-huh.
And the way we thought about it is the bee is currently on the ground.
Okay.
So its toes are touching the ground. And
okay.
if you want it to move up to the top of the flower, the flower is 3 meters high, so it needs to move 3 meters to get its toes touching the top of the flower.
Ah, okay. So you were saying we assume the bee starts off on the ground, and then he's going to need to move up 3 meters to be on the 0.3 meters to be on the top of the tulip, because the tulip is 0.3 meters up. So all you C people, well, why not? Come on, that sounds right. Oh, right behind you there, Michael.
Since you had told us that the bee's center for this object is like halfway in between it, if it were actually on the ground, then it would be like underneath the ground. You know what I mean? Like
Okay.
the middle of the bee would be on the ground, but it's not. The center's a little bit above the ground, so it does just need to go the height of the tulip plus half of the bee's height up.
So it seems like we need to know where the heck is the bee, right? Is he on the ground? Is he halfway into the ground? Is he whatever? Up the stairs, down the stairs. Go ahead.
I think you also said that each animation has its own center.
Yeah.
So that means if it's moving to tulip, you don't know how far up it has to move, because the animator could have put the center at the very top or at the very bottom.
Okay. So the key thing that I would like that you brought up here is it says bee move to tulip. That's the first thing that happens. So the bee moves to the tulip. And at that point, that's whenever we see move to, we need to know where the heck is the center of this thing. Because the move to command, as we said in the previous slide, is going to make the centers of two things overlap. So when we do the first instruction, bee, move to tulip, that's going to make the bee move. I think I need like a new color, but that's not going to, no, okay, well, let's try that color. That's going to make the bee's center overlap with this center. So the bee's center was in the middle, so in fact the bee is going to be like, and because the bottom of the tulip, assuming it's on the ground, or the center of the tulip is at the very bottom, then that's going to make the very center of the bee go to the very center of the tulip, so the bee is going to be halfway underground. Or moreover, his center is going to be right at the bottom of the stem. So at that point, since we know that from here up to the very here is 0.3, one of the first things we could do is have him move up 0.3, but that would just put his center, right? That would put his center at the top of the flower, and he'd kind of be overlapping. He would not be standing on top, okay? So this is why we have this code right here. It says, bee moving up the tulip's height, which again is 0.3, but then we add on the bee's height, all right, which is 0.1, but we don't want to move it all the way up the bee's height because half of the bee's height is actually already above the tulip top. So we just need to get that last half to get his feet up there. So we divide that by 2, and 0.1 divided by 2 is 0.05. That is literally the extent of math we will need in this class. Well, on an exam, that's all you need to be able to do. So we add 0.3 and 0.05, and we get 0.35 in this case, all right? So again, the key things to know about is that the move to causes the two centers to overlap, and then this is finally a reasonable reason that we might write an expression out because we can't calculate it for it. It would depend on the sizes of our tulips and our bees. And so if we would want to change their sizes, we'd want them to be able to do that. All right, so we had pretty good round of voting there on 90, but this is a challenging concept. We were sort of all over the place before then. So again, first thing we could just do is plug in those numbers, and that's definitely something to do on a test. But here in class, we want to learn about why we're doing that, okay? So hopefully this expression and why we wrote it actually makes sense.